Welcome to Hyperbolas. This is section 10.4 in your book. We're going to start by just talking about what they are. So here, the definition of a hyperbola. The official definition is it's a set of all points in a plane, the difference of whose distances from two distinct fixed points is a positive constant. So if we look at our diagrams, what they're talking about is we have our focus and our focus. And then we're given a point that sits on the hyperbola. So this part, D1, that represents one of our constants. And then the distance from the opposite focus to the given point is D2. When we subtract these differences, we get a positive constant. So if we look over here, this kind of lays out the parts of the hyperbola. So the first part we have, these are called the branches. That's the actual hyperbola, really. Then we have our vertices. So essentially hyperbolas are just like mirror images of parabolas. So if you notice, it's the same shape. We still have a vertex. And then we have a focus, which again sits inside the arc. The center sits an equal distance away from each of the vertices. It also sits an equal distance away from each of the foci, or foci. Now, the distance between both of our vertices, that's what we consider the transverse axis. So the transverse axis is the axis, the vertices, foci, and branches sit on. And once we look at the equation of a hyperbola, we'll be able to easily and quickly identify where our transverse axis is, if it's x or y. All right, so now let's look at the equation of a hyperbola. See if I can get this to slide down just a tiny. Of course not. Oh, so frustrating. All right, so back to the equation. Sorry. So as you notice in the box, we're told that this is the equation if the transverse axis is horizontal, and here's the equation if it's vertical. So what we're really looking at is not the A and B anymore, but what we're looking at is which is positive and which is negative. So if you notice, this says the transverse axis is horizontal, which means it would run along the x-axis. Horizontal. There you go. So if you look up here, and notice, x is positive, y is negative. So the positive value is our transverse axis. So our next one, we have y minus k squared over a squared minus x minus h squared over b squared equals 1. So pay attention, the a and b squared, they're not moving back and forth like they did with the ellipse. They stay put. What's changing is our numerators. Those go back and forth, and that depends on our axis. So here, because y is positive and x is negative, then that means y is going to be our transverse axis, and it's vertical. So that's the easy way you can tell which is which. Same holds true if the center of our hyperbola is at the origin. Now, again, if you look at the drawing here, the center is an equal distance away from both sides, and the center is still identified as H and K. And so here's our center. All right, the thing we use to help us sketch out our hyperbolas are the asymptotes. The asymptotes are actually what forms the shape so that we can put the branches in. And we use a formula to help us find the asymptotes. And this is y equals k plus or minus b divided by a times k minus h. This is for the horizontal on the transverse axis, and then flip a and b for the transverse axis to be vertical. So here's what it actually breaks down to. So for our horizontal, I'm just going to do an h. Y, that's going to stay as a variable. You're not going to change it. K, this is, I'm going to write over to this side. Okay. So K, remember, represents the y coordinate. From the center. Remember, this is the midpoint between your two branches. So right here, that's our K. It's the y coordinate from the center. Plus or minus. B. B is the distance from the center up the conjugate axis. So that's kind of the minor axis. To conjugate vertex. Aha. Then A. A is the distance from the center to our vertex. That's what we call like our actual vertex right here. Or you could call it the transversal vertex if you want to get fancy. Then we have x, which stays as your variable, not going to change, minus h, and h is the x coordinate. From the center, okay? And you just plug these values in, and it helps give you the equation of the asymptote. And we'll look at that on some of the examples that we're about to work. The examples really kind of help solidify the information. So we're going to look at a few of the problems from our classwork. So the first thing is number 5. So we have x squared minus y squared equals 1. We have to identify the center, the vertices, the foci, the equation of the asymptote, and sketch the hyperbola. So there's a lot going on. So first of all, let's look at a few things. The center. Well, remember, that's h and k. So we have 0, 0. Because x is our positive term, that means that our transverse axis is horizontal. Okay? And let's see. Okay. Now, sorry, just looking at my notes. So I'm going to rewrite this real quick so you can see what was actually throwing me off. Because I didn't have my denominators, That's where I kind of spaced as to A and B. So to help us sketch and find everything, A is going to be 1. Because remember, this is A squared. So the square root of A squared gives us A. B is also going to be 1. Now C represents the distance from the center to the foci. And C is going to look familiar. C squared equals A squared plus B squared. So for us, that's going to be C squared equals 1 squared plus 1 squared. So C squared equals 2. So C equals the square root of 2. So now that we know what A and B are, I can find my vertices and my foci. So my vertex, I'm going to erase this and write down the side so I have room. Okay, so my vertex is going to be at plus or minus 1, 0. Let me sketch this real quick. Alright, so center is at the origin. Then I have a vertices here and here. Now I need to use B to help me figure out how to draw my branches. And here's the trick. Draw a box. Okay, so notice my box extends only to my vertices and then the vertices on my conjugate axis. Okay, now to get the asymptotes, I'm going to go from my center and extend a line out through each corner of my box. Now keep in mind, mine's not precise, so that could cause an issue. You'll want to use a ruler. And then I'm going to draw my hyperbola so that it extends close to, but not over, my asymptotes. Now to find the equation of our asymptotes, we use y equals k plus or minus b divided by a times k minus h. So y equals 0 plus or minus 1 over 1 times x minus 0. Well, that's just y equals x. And if you look at the lines, as poorly drawn they may be, it does make sense. Oh, and then the last piece, the focal points, are foci. Because we're moving along the x-axis, that means we're going to have a change in the x-coordinate. So I'm going from 0, and I'm either going to be adding or subtracting square root of 2 to 0. So here's everything we need. We have the center, we have the vertices, we have the foci, we have the equation of the asymptotes, and we have a sketch. So let's move on, and we're going to look at number 13. Because number 13 has completing the square, and I don't feel like y'all can see that enough. All right. First thing is we're going to group. So we have 9x squared minus 36x, then minus y squared minus 6y, and I'm going to move the 18 to the other side. Factor the 9 out. I'm going to factor a negative out. Complete my square. So remember, this is 4 divided by 2 is 2. 2 squared is 4. And then here we have 6 divided by 2 is 3. 3 squared is 9. And because I added 4 times 9, that would be 36. And then here I have 9 times negative 1, so that's negative 9. That leaves us with 9 times x minus 2 squared. So remember, take the square root of your first term, take the sign from your second term, and the square root of your third term. So again, square root of the first term is y, sign from the second term, square root of my third term. And all of that equals up to 9. We're going to divide everything by 9. And so that leaves me with x minus 2 squared over 1 minus y plus 3 squared over 9, and that equals 1. So let's start. We have a center at 2, negative 3. We have vertices at, this is a good question. So let's look. We have A, we have B. Go ahead and have C while we're at it. So A is 1, B is 3, and then C is going to be the square root of 10. Because remember, C is the square root of A squared plus B squared. So you just add your denominators together. Okay. So because x is first, that means our transverse axis is horizontal. So I'm going to be moving along the x-axis. This says I'm going to move 1 left and right from the x-axis. So 1 to the left is going to be 1, negative 3. 1 to the right is 3, negative 3. So these are my vertices. The foci, I'm going to be moving square root of 10 plus or minus. So we write 2 plus or minus square root of 10, negative 3. There, that's a 3 for real. Then our asymptotes, because it's horizontal, we're going to use y equals, oops, I don't know what I did, equals k plus or minus b over a times x minus h. So I have y equals k is negative 3 plus or minus b divided by a is just 3 times x minus 2. That's the equation of our asymptote. All right, let's see. What else do I have for us to look at? All right, we're going to look at 2 more, 21 and 31. 21 and 31, you're given pieces. And you have to sketch the hyperbola. I think. I'm going to check. Hold on. Okay, now. We're just finding the standard equation. So here we go. 21. We're given that we have vertices at 0, plus or minus 2, and our foci are at 0, plus or minus 4? Well, because the vertex and the focus both appear to be on the y-axis, I'm going to say that our transversal axis is vertical. So that means that we're looking at y minus k squared over a squared minus x minus h squared over b squared equals 1. So I can get the center, because I know that the center is going to fall halfway between these, so it's at the origin. So that's just going to be y squared over a squared minus x squared over b squared equals 1. From the vertex, I can find out that A is 2. Because if you sketch this out, you'll see that, call this positive 2, negative 2 with the center. So A, obviously going to be 2. So that gives us y squared over 4 minus x squared. And we have to find b squared, but we can't get b squared. However, the foci gives us c. So if this is positive 4 and this is negative 4, then the distance from the center to the focus here is 4. So we know that A equals 2, we don't know B, and we know C equals 4. We also know that C squared equals A squared plus B squared. So let's just fill in what we have. 16 equals 4 plus B squared. All right, well, I'm not going to subtract because we all know that B squared equals 12. And there's our equation. All right, now let's look at 31. Last one. 31, we have vertices at 2, negative 3, and 2, positive 3. We're also just given a point at 0, 5. So first thing, we're going to figure out which equation are we using. So if you look at the vertices we're given, you should notice the movement is along the y-axis. So it's horizontal. It's going to be y minus k squared over a squared minus x minus h squared over b squared equals 1. I always sketch it quickly because this is kind of how I have to see it. Alright, so this is 2, 3, this is 2, negative 3. So my center is going to be at, poorly drawn note AB, 2, 0. So I have my center is at 2, 0. So that's going to be y squared over a squared minus x minus 2 squared over b squared equals 1. And then this is 3, so that gives us a. So that's y squared over 9 minus x minus 2 squared over b squared equals 1. Now we can't get c. So what do? Well, that's where our point comes in. We have an x value and a y value, so we're going to plug them in and solve. So this says y is 5. So it's 25 divided by 9 minus, this is 0, minus 2 squared, which is 4, over b squared equals 1. Now I'm going to multiply and get a common denominator. It makes it a little easier. So I have 25 b squared minus 36 over 9b squared equals 1. multiply 9b squared by both sides. I'm working over here now. So I have 25b squared minus 36 equals 9b squared. Do a little swapping. 25 minus 9 gives me 16b squared equals 36. When I divide, I get that b squared equals 36 over 16, or 9/4. So I come back to b squared, and if I was to put 9/4 in here, that would be awkward. So we flip it, and it becomes y squared over 9 minus 4 times x minus 2 squared over 9 equals 1. Oops, I cut my 1 off. Let's try this again. There. Okay. And there is our answer. So we will be working on classwork when we see you next week. Be sure and double check the schedule. Know what room you're going to be in for testing. Pay attention to what days that we will see you in class. And as always, we're all here in the afternoon, and we would all love to see you if you need any help. Seniors, have a good weekend. Be safe, and we hope to see you all on Monday. Bye, guys.